All right, some of the questions based on the NEET series. The first one, an aqueous solution was prepared by dissolving 18 grams of glucose in 90 grams of water. A relative lowering of vapor pressure would be. Now, there are colligative properties, 4 colligative properties. One is relative lowering of vapor pressure, relative lowering of vapor pressure. In order to calculate the relative lowering of vapor pressure, we know that according to Raoult's law, P naught minus P divided by P naught is called as relative lowering of vapor pressure, which is equal to mole fraction of the solute. Mole fraction of the solute. NB is the number of moles of solute. Na is the number of moles of solvent. This is the colligative property. The second colligative property we have is osmotic pressure. This osmotic pressure is represented by letter pi. We know that pi v is equal to nRT, or we can write pi is equal to n by v RT, or we also can write pi is equal to C into RT. This is osmotic pressure. The third is elevation in boiling point. Now, this elevation in boiling point is represented as delta TB. Delta TB is equal to 1000 into kb into W to weight of solute divided by molecular mass of solute into weight of solvent. This is the formula to calculate elevation in boiling point. Likewise, the fourth we have is depression in freezing point. Depression in freezing point is represented as delta TF. It is equal to 1000 into Kf, molar depression constant, into W2 divided by M1, M2 into W1. This is the formula to calculate the freezing point. Now, the question is, they're asking us to calculate the relative lowering of vapor pressure using this data. Now, they've given 18 grams of glucose. 18 grams of glucose. Now, they've given the mass of glucose, so it's possible for us to calculate the number of moles. Number of moles of glucose is calculated by the formula weight in grams by molecular mass. Weight of glucose they've given us 18 grams. Molecular mass of glucose, it is 180. You should remember this. C6H12O6 is the molecular formula. Molecular mass is 180. Therefore, the answer for this will be 0.1 mole. Similarly, they've given 90 grams of water. So, since they've given 90 grams of water, the number of moles of water is given by the formula weight of water divided by molecular mass of water. That is 18. So 5 is the number of mole of water. Now the question is, they're asking relative lowering of vapor pressure. The relative lowering of vapor pressure is directly proportional to mole fraction of the solute. Glucose is the solute and water is the solvent. So mole fraction of glucose will be equal to number of moles of glucose divided by number of moles of glucose plus number of moles of water. That will be equal to number of moles we found out glucose will be 0.1 divided by 0.1 plus 5.0. That will be equal to 0.1 divided by 5.1. On simplification, we will get 0.02. So therefore, the answer for this question is option 1.02. So you should remember 4 formulas in order to calculate the molecular mass or relative lowering of vapor pressure. So colligative property based questions can be asked. The second question, if molar conductance of 0.1 molar weak electrolyte, ammonium hydroxide is a weak electrolyte. So the concentration of ammonium hydroxide they've given as 0.1 molar. The conductance, the molar conductance they have given for ammonium hydroxide not ammonium hydroxide. Molar conductance, if molar conductance of 0.1 molar ammonium hydroxide is 35. So molar conductance of ammonium hydroxide is 35 Siemens centimeter square per mole. And molar conductance at infinite dilution of ammonium chloride. So ammonium chloride, they've given molar conductance of ammonium chloride. So lambda m at infinite dilution, they've given us 300. Likewise, molar conductance of NaOH at infinite dilution, they've given us 150. And molar conductance at infinite dilution for sodium chloride, this is for NaCl, this is for NaOH. Sodium chloride, they've given us 100 Siemens centimeter square per mole. And they're asking, what is the dissociation constant of weak electrolyte? See, dissociation reluctance of an electrolyte at a particular concentration divided by molar conductance of the same electrolyte at infinite dilution. So this is the formula to calculate the degree of dissociation. Once we know the degree of dissociation, we can calculate dissociation constant Ka by the formula C into alpha square. C into alpha square. Now, in order to see lambda m, they have given lambda m for ammonium hydroxide, they have given 35 Siemens centimeter square per mole. But lambda m infinity, we don't know for this weak electrolyte. How do we calculate lambda m infinity for ammonium hydroxide? This is based on Cold-Rush's law. So we can calculate this as lambda m of ammonium chloride plus lambda m infinity of sodium hydroxide minus molar conductivity at infinite dilution of sodium chloride. So what happens? This sodium and this sodium gets cancelled. This chlorine and this chlorine conductivity will get cancelled. So we have only ammonium ion and also hydroxyl ion. So therefore, it will be conductance of ammonium chloride is 300 plus sodium hydroxide, it is 150 minus for sodium chloride, it's 100. So it will be 350 Siemens centimeter square per mole. This is the molar conductance of ammonium hydroxide at infinite dilution. Once we know this, we can find degree of dissociation. They have given molar conductance at a particular concentration, 0.1 molar is 35 Siemens centimeter square per mole. Infinite dilution, we calculate it's 350. So it will be 35 divided by 350 will be 0.1. So Ka will be equal to concentration, we know it is 0.1, and alpha we the whole square. So that will be equal to 10 to the power minus 3. Hence, the answer for this question is option 2. The next question. Which of the following statements is our expansion? Minimum amount of work can be obtained by a reversible path rather than through an irreversible path. Reversible path rather than an irreversible path. In case of compression, minimum amount of work can be done on the system by carrying out process irreversibly than reversibly. Both statement 1 and statement 2 are incorrect. Statement 1 is correct, statement 2 is incorrect. Statement 1 is incorrect, statement 2 is correct. Both statement 1 and 2 are correct. Work done is maximum during reversible expansion. Reversible expansion process and irreversible compression. So therefore, for this statement, statement 1 is correct. For isothermal expansion, minimum amount of work can be obtained by reversible path rather than irreversible path. So work done as maximum during reversible expansion process and irreversible compression. Here it's expansion, maximum work. So therefore, statement 1 is right and statement 2 is. The next question. What will be the heat of formation of methane if heat of combustion of carbon is minus 6 kilojoules? Combustion is an exothermic reaction, therefore it's minus. Heat of formation of water is also combustion reaction, combustion of hydrogen, the exothermic, minus Y kilojoules. And heat of combustion of methane is minus Z kilojoules. Combustion reactions are exothermic. So in order to prepare methane, we need carbon, we need hydrogen. Carbon and hydrogen, when we heat, we get methane. So enthalpy of the reaction, delta HR is equal to delta H of methane, that is equal to summation of enthalpy of reactant minus enthalpy of the product. Now we know that delta H of methane is equal to reactants. The reactant here is carbon and hydrogen. So carbon, they've given combustion as minus X, and hydrogen they've given as minus Y. So 2 in plus of 2 into minus Y. H to 2 moles of hydrogen we have, therefore 2 into minus Y. Minus of combustion of methane they've given. They're asking formation of methane. Combustion of methane they've given us minus of product is methane. So product is minus Z. So on simplification, we get minus X minus 2Y plus Z. Open up the brackets so you will get this. Minus into minus is plus. So answer for this question is option 4. And the energy is in terms of kilojoules. You can write kilojoules. Next question. The resultant pH of mixing of 200 ml of aqueous solution of HCl with 300 ml of NaOH, pH 12.0. They've given 12 point pH they've given. If they're given concentration, working pattern will be easy. But anyways, first we will try to understand this. Hydrochloric acid is a strong acid. Hydrochloric, HCl is a strong acid. They've given the pH of HCl to be 2. Since the pH of HCl, we know the definition of pH. pH is negative logarithm to the base 10 of H plus. Since pH is given 2, the H plus ion concentration, if we calculate, if you take this to the left-hand side, it becomes anti-log of 2. So H plus ion concentration can be understood as 10 to the power minus 2. H plus ion concentration is 10 to the power minus 2. In square brackets, we will write concentration 10 to the power minus 2. Similarly, they've given NaOH. They've given pH to be 12. When they've given pH to be 12, we know that POH is 12. 2. POH is 2. Because we know pH plus POH is equal to 14. So POH will be equal to 14 minus pH. It will be equal to 14 minus 12. Because POH they've given to be 12. So it will be 2. POH is 2. When POH is 2, we also know that POH is given by the formula negative logarithm to the base 10 of OH minus. So OH minus ion concentration will be equal to 10 to the power minus 2. Here also OH minus ion concentration will be equal to 10 to the power minus 2 molar. 10 to the power minus 2 molar. See here, HCl is an acid and NaOH is a base. Acid and base will react. Acid and base will react. When we say acid and base will react, the normality of the resulting solution, they're asking mixed with aqueous solution of NaOH. What's the pH? So normality of the resulting solution, we can write it as N1V1 minus N2V2. Maybe we'll take this as HCl or M1V1, we can write molarity M1V1, M2V2 of NaOH. So resulting molarity will calculate divided by V1 plus V2, total volume. So M1 is 10 to the power minus 2. Volume of HCl is 200. See, the volume of HCl is 200. So what we will do is, since the concentration of H plus and OH minus is same, volume of HCl is 200 and volume of NaOH is 300. What we will do is, we will take this as NaOH and this we will take it as HCl because the concentration of NaOH is more. So 10 to the power minus 2 into 300 minus of 10 to the power minus 2 into 200. Total volume is 300 plus 200. So if we simplify this, we get the normality. Since the concentration of NaOH is more, we can say the molarity of OH minus resultant solution. So it will be 100, 300 minus 200 will be 100, and 10 to the power minus 2 is common, 10 to the power minus 2 divided by 500. So it will be 1 by 5, 10 to the power minus 2, or we can write this as the value we will get is value. What we will get is around 1 by 500. Otherwise, we will write this as this value instead of writing simplifying. So we'll get this as 2 into 10 to the power minus 3. 2 into 10 power minus 3. So this 2 into 10 power minus 3, this is the normality of molarity of the resulting solution. So they're asking you to calculate the pH. So I will write, so pOH will be equal to negative logarithm to the base 10 of 2 into 10 power minus 3. So pOH, we will get it as 2.7. 10 to the power minus 3 log 2, 2.7. So pH will be 14 minus 2.7. That will be equal to 11.3. The answer for this question is 11.3. See the confusion, 11.03, 11.3. Close it is. So the exact answer is 11.3010. So these kind of questions. So until you know all the formulas, you cannot work the problem. Next question. 5 moles of hydrogen gas, 3 moles of white phosphorus, and 12 moles of oxygen gas are taken in a sealed flask and allowed to react as follows. Allowed to react as follows. So it will be H2 plus P4. It's a solid. Hydrogen is a gas. Phosphorus is a solid. Plus oxygen. Oxygen is a gas. And we get phosphoric acid, H3PO4. It's an unbalanced equation. So we'll in order to balance this equation, it is this 6 moles of hydrogen and 4 moles here. Phosphorus is 4, 16. 16 means it will be 8. Now, the moles of orthophosphoric acid that can be produced, considering the reaction occurs in 100% yield. 100% yield. Now, as per the reaction, if you observe the reaction carefully, hydrogen is a limiting reagent. Hydrogen is a limiting reagent. So the reaction depends on hydrogen. Hydrogen is the limiting reagent. What is limiting reagent? A reagent which is completely consumed in the reaction is called as a limiting reagent. Or a reagent which decides the amount of product form is called as a limiting reagent. So as per the stoichiometry, we see that 4 moles of phosphorus and 6 moles of hydrogen. Therefore, the number of moles of phosphoric acid formed is given by 4 divided by 6, and the number of moles of hydrogen taken is 5. So it will be equal to 3.33 moles. The answer is option 3. The next question. A graph between half-life period, T half is half-life period. Half-life period. And the concentration of nth order reaction is a straight line. We don't know what's the order. Nth order they've given is a straight line. Reaction of this nature is completed 50% in 10 minutes when the concentration is 2 mole per liter. This is decomposed 50% in T minutes at 4 mole per liter value, N and TR. They're asking the order of the reaction as well as the time, order of the reaction and time. Now, for a first order reaction, we know that half-life period T half is equal to 0.693 by K. Now, T half is a constant. First order reaction, for a first order reaction, same percentage of first order reaction is complete in the same time. Same percentage of first order reaction is complete in same time. Whatever will be the initial concentration, whatever will be the initial concentration. So therefore, time required for 50% reaction will be equal to 10 minutes. We clearly say a graph of T half and concentration for nth order reaction is a straight line. Reaction of this nature is 50% is completed in 10 minutes. So when we say 50% is completed in 10 minutes, it means it's a half-life period. So now for a half-life period, how is half-life period related to order? Half-life period is inversely proportional to a to the power n minus 1. So for a first order reaction, we can see n is 1. When n is 1, T half is proportional to a to the power 1 minus 1. So that's a to the power 0. Anything to the power 0 is 1. So that means half-life period is independent of concentration. Since half-life is independent of concentration, we get a straight line parallel to the x-axis. So therefore, the answer to this question is a first order reaction and the half-life period is 10 minutes. So all these values, whatever is being mentioned, is only to confuse, to create curiosity. The next one, equivalent weight of a bivalent metal is 37.2. Equivalent weight of a bivalent metal. What do you mean by a bivalent metal? A metal whose valency is 2 is called as a bivalent metal. They have given the equivalent weight to be 37.2. And the question is, they're asking the molecular weight of its chloride. They're asking the molecular weight of chloride. It's chloride. So now when we say chloride, the valency of chloride is 1 because Cl minus. Metal is 2 plus, chloride is minus 1. That means the molecular formula of the metal chloride, is equal to M2 plus, therefore 2Cl minus we need, it is MCl2. This is the molecular formula of the metal chloride, MCl2. Now the question is, they're asking calculate the molecular weight. Now you should remember, for an element, equivalent weight is calculated by the formula atomic weight by valency. So they've given equivalent weight as 37.2. Atomic weight we don't know, and we know that it's a bivalent. That means valency is 2. So atomic weight of the metal is 37.2 into 2. It will be 74.4 atomic weight. Now, since they're talking about metal chloride, 74.4 plus of 2 into 35.5. Chlorine atomic mass is 35.5. Since 2 chlorine atom, 2 into 35.5. Therefore, it will be 74.4 plus 71. It will be 145.4. Therefore, the answer for this question is option 3. So you should remember this formula to calculate the equivalent mass. Equivalent mass is calculated by the formula atomic weight by valence. Equivalent weight of an element it is. It's not of an acid, nor a base, nor the oxidizing or reduction agent. So it is only for an element. So equivalent weight of element is calculated by the formula atomic weight by valency. The next question, the ratio of specific charge of a proton and an alpha particle is specific charge. What is specific charge? So specific charge is defined as charge by mass. Charge by mass is called as specific charge. Now, what is the specific charge of a proton? Specific charge of a proton. Proton is H plus. Plus 1. Proton we represent as plus 1. So 1. And the atomic mass of hydrogen is also 1. So what will be the specific charge of alpha particle? Specific charge of alpha particle. Charge on alpha particle is 2. Atomic mass of helium is 4. So the ratio they're asking. So ratio will be specific charge of proton divided by specific charge of alpha particle. That will be equal to 1 by 1 divided by 2 by 4. On simplification, we will get 2 by 1 or 2:1 ratio. So therefore, the answer for this question is option 1. It is a simple question. You should know the charge and mass. The number of unit cell in 58.5 grams of NaCl, number of unit cells in 58.5 grams of NaCl. So you should remember, we have learned simple cubic lattice, body-centered cubic lattice, face-centered cubic lattice. So number of particles for simple cubic lattice is 1, body-centered cubic lattice is 2, and face-centered cubic lattice is 4. Now, NaCl belongs to face-centered cubic crystal system. So number of particles in NaCl is 4. So before that, so they've given the weight of NaCl, we'll calculate the number of moles. So number of moles of NaCl is weight in grams by molecular mass, that is 58.5 divided by molecular mass of NaCl is also 58.5 because sodium is 23 and chlorine is 35.5. So number of moles is 1. So number of particles here, number of particles is 1 mole contains Avogadro's number of particles, 6 into 10 power 23, approximately 6 into 10 power 26.022 and 10 power 23, 6 into 10 power. 1 unit cell, you should remember, 1 unit cell in NaCl contains 4 molecules. That is what we learned here, 4 molecules. Therefore, number of unit cell in this number of particles will be 6 into 10 power 23 divided by 4. That will be equal to 1.5 into 10 to the power 23. So therefore, the answer for this question is option 3. Option 3. Now, so the next question, Match the column 1 with column 2. Boils temperature, inversion temperature, critical temperature, critical pressure. Now, Boyle's temperature. Boyle's temperature is A by RB. A, R is a gas constant, B is also a constant. Inversion temperature is 2A by RB. Critical temperature is 8A by 27 RB. And critical pressure A by 27 P square. The answer for this question is, the first one is matched. Inversion temperature is 2A by RB. Critical temperature is 8A by 27 RB. And critical pressure is also balanced. Therefore, the answer for this question is option 2, second option. The next question, 32 ml of helium gas effuses. It's not diffusion. Effusion is escape of gas from a minute pore, or the hole is called as effusion. 32 ml of helium gas effuses through a fine orifice, small hole, in 1 minute. Then volume of methane effused in the same time under similar condition. It is based on the Graham's law of diffusion. So rate of diffusion of helium, 32 ml of helium gas. So rate of diffusion is inversely proportional to square root of its density. That is Graham's law of diffusion. Density is mass by volume. Density is mass by volume. So we can write R is proportional to square root of 1 by m by v, or we can write R is proportional to square root of v by m. Now, for helium, we can write rate of diffusion of helium is equal to or proportional, constants will cancel, will be square root of helium 32 ml, and the mass of helium is 4. Similarly, rate of diffusion of methane, that will be equal to square root of molecule volume of methane we are supposed to find. Then volume of methane we're supposed to find, we don't know, V. Molecular mass of methane is 16. CH4, the molecular mass of methane is 16. So rate of diffusion of helium to rate of diffusion of methane, if you take, it will be square root of, maybe this can be written as 16 by, you can write a square root of 16 by 4, that will be equal to 32 by volume of methane, that will be equal to 2. Therefore, volume of methane is 16 ml. 16 ml. ml. Therefore, the answer for this question is option 2. Which of the following statements are correct about melamine formaldehyde polymer? Melamine formaldehyde polymer. It is formed by condensation polymerization. It is used in the manufacturing of unbreakable crockery. A resin intermediate is formed during the process of polymerization. All statements are correct. So it's a resin intermediate formed during the process of polymerization. The answer is option 3. Thin layer chromatography is of type of adsorption chromatography, partition chromatography, paper chromatography, thin layer chromatography. So the principle in thin layer chromatography is adsorption. We will have two phases. One will be a stationary phase, and the other one will be a mobile phase. Depending on the adsorption ability of the solute, the mobile phase will carry. Now, if we, this is a stationary phase, if you understand, if the stationary phase is kept in a solvent, this solvent is a mobile phase. This is stationary, it cannot move. So what happens is, now this, due to the capillary action, what happens? The solvent starts moving. So now it will carry different molecules to different levels because different molecules will have different adsorption ability. So therefore, thin layer chromatography is a type of adsorption chromatography. The next one is isopropyl alcohol. Isopropyl alcohol is a secondary alcohol. OH group attached to secondary carbon atom. OH group attached to secondary carbon atom. Now, isopropyl alcohol is a secondary alcohol. So isopropyl alcohol, the formula is CH3, CH, OH, and CH3. Here the carbon atom is a secondary carbon atom. Why this carbon atom is a secondary carbon atom? Because this carbon is bonded to two other carbons, therefore it's a secondary carbon atom. Now, isopropyl alcohol is a secondary alcohol. OH is attached to secondary carbon atom. Both assertion and reason are true. Reason is correct explanation for the assertion. Therefore, the answer for this question is option 1. Which compound gives more stable carbocation on heterocyclic cleavage of carbon-bromine bond? So you can see it's all heterocyclic compounds, and they're asking which of them gives the most stable carbocation. The most stable carbocation is given by this. Now we'll denote this ANH. This is a bromine. So nitrogen has a lone pair of electrons. Now what happens is, this bromine, if it's been lost, we get NH here, a lone pair of electron, and we have a positive charge on this carbon. This is stabilized by complete orbital state. Therefore, this molecule is more stable. Option 3 is more stable. The next question. Which of the following correctly shows the order of decreasing basicity? So you should remember, basic strength is directly proportional to molecule showing plus M effect or plus I effect, and basic strength decreases with molecules showing minus M effect or minus I effect. So electron donating groups increases the basicity. Electron, like for an example, in case of aniline, aniline is an aromatic. This NH2 is an electron donating group. But in case of electron donating, if it's aromatic, it's not so. Here the availability of electrons decreases, therefore basicity decreases. So which of the following shows the order of decreasing basicity? Now, aniline, now if we take aniline, as I told you, due to the resonance effect, the electron will be less available on nitrogen. So therefore, aniline will be less basic. Now compared to metanitro-aniline. Metanitro-aniline. This is aniline and this is metanitro. Aniline is less basic, more basic than metanitro because this is electron donating group. So it puts the electron towards more. So aniline will be a stronger base than metanitro, and that will be stronger base than paranitro, and that will be stronger base than orthonitro aniline. So therefore, the answer for this question is option 3. The next question. Which of the following is wrong about resonance? Resonating structures having same energy have some contribution to resonance hybrid. Position of atoms do not remain the same in resonance. All resonating structures have same number of paired electrons. All resonating structures have same amount of net charge. Which of the following is wrong about the resonance? Position of atoms do not remain same. So position of atom remains the same. Only the pair of electrons, lone pair of electrons or pi electrons shifts. Position of atom remains same. Here they say position of atoms do not remain same. So this is the wrong statement. Therefore, the right answer for this question is 2. The next question. Match list 1 with list 2 and then select the correct answer from the codes given below. Butane to isobutane. Butane is CH3, CH2, CH2, CH3. Isobutane is CH3, CH, CH3, CH3. This is an example for chain isomers. So for butane, the correct option is this. Butane to lower hydrocarbons. So breaking a big molecule into smaller molecules is called as cracking. So for the second one, it is option A, cracking. So normal heptane, this is first. Third one, normal heptane to toluene. See, normal heptane is the open chain compound. Toluene is aromatic. Toluene is aromatic. It has a benzene ring and it has a CH3 group. So therefore, normal heptane to toluene is aromatization. Propane to this sulfonyl chloride, it's called as a Reed's reaction. We do not have Reed's reaction in our syllabus. So therefore, answer for this question is option 1. The next one. A compound with molecular formula C4H10O gives yellow precipitate with iodine and sodium hydroxide. Iodine and sodium hydroxide. Then the compound can be. See, this is called as iodoform test. Iodoform test. Molecules containing methyl carbinol groups gives iodoform tests. Molecules which contains methyl carbinol. What is this methyl carbinol? A methyl group, CH and OH. This group is called as methyl carbinol. So any molecule which contains methyl carbinol group will give iodoform test. Here, if you observe, only this molecule, the second one only gives as what? Methyl carbinol. Since the second one has methyl carbinol group, it will answer iodoform test. Hence, the answer for this question is option 2. Hello? Put it. So the answer for this question is option. Next one. Which type of detergent is formed when stearic acid reacts with polyethylene glycol? Polyethylene glycol, stearic acid, and polyethylene glycol. Stearic acid is C17H35COH. Ethylene glycol is CH2OH and CH2OH. Now, the type of detergent formed. So this is a long chain. If this undergoes dissociation, we get C17H35COO minus. So this has a negatively charged. Therefore, it will be called as anionic detergents. Hence, the answer for this question is option 1. It forms anionic detergent. Next question. Following reaction, the reason why meta-nitro product also is formed. The reason why meta-nitro product is also formed. Now, we all know that electron donating groups are ortho-para directing group. So this NH2 is an electron donating group. So therefore, it will allow the reaction to take place ortho position and para position. But if you observe this molecule carefully, it's also giving you meta compound. It's also giving you meta. Only you should get ortho and para. It should give ortho and para, but it's also giving you meta. 47% it's giving you meta. Why it is giving 47% meta? Because now when aniline is allowed to react with an acid, what happens? This aniline is a base. This aniline is a base. It has a lone pair of electron. But when it's allowed to react with an acid, what happens is this lone pair of electron is given to H plus, and we get a group like this. We get NH3 plus. This is called as anilinium ion. It is called as anilinium ion. This anilinium ion is an electron withdrawing group. Since it's an electron withdrawing group, it is meta-directing group. See, this is NH3 plus. It's an electron withdrawing group. Therefore, it's meta-directing group. Therefore, we also get meta product here. 47% meta product we get. So in this following reaction, due to the reaction of aniline with acid forming anilinium ion is an electron withdrawing group. Because of the positive character, it will undergo minus I effect. Hence, it will direct the reaction to take place at meta position. Hence, the answer for this question is option 3, formation of anilinium ion. Next question. RNH2CHCl3KOH gives you RNC, 3KCl, and 3H2O. It is a very well-known reaction. There's nothing to explain this, because you would have learned this reaction for your regular exams. So we get RNC plus 3KCl plus 3H2O. The above reaction is known as HBZ reaction, carbylamine reaction, Colbase reaction, and Hoffman's bromide reaction. Formation of isocyanates. It's carbylamine reaction. Chloroform and KOH gives you carbylamine reaction. The next one. It's a carboxylic acid. They've given a carboxylic acid like this, Me, C double bond O, we have CCOH. We have an acid, and also we have a ketone group, carbonate. We have two reactants. One is that we have Na, so NaBH4, sodium boron hydride, and here we have lithium aluminum hydride. Here it is A, and here the product is B. You should remember sodium boron hydride is a weak reducing agent. Weak reducing agent. So it reduces only the carbonyl ketone group, C double bond O group. But lithium aluminum hydride is a strong reducing agent. So it reduces both C double bond O ketone group and the carboxylic acid group. Therefore, the product what we get is here. What is this? So the B will be MeCOH CCOOH. Because NABH4 is weak, it only reduces this. But A will be Me, methyl group COH, C, and you'll get what? One more OH group, a long chain OH group. So the answer for this question is this. This is A and this is B. This is B. The next question. Which of the following is a pseudo inert gas ion? Which of the following is a pseudo inert gas ion? Zn2 plus, Cu plus, Cu2 plus, both 1 and 2. So an element with pseudo noble gas configuration has 18 electrons in the outer shell. Instead of 8 electrons. It is called as pseudo inert gas. So inert ion here, inert gas ion. Therefore, the answer is Cu plus. Cu plus will have 18 electrons in the outermost shell. Therefore, it is called as pseudo inert gas ion. Ma'am, I'll stop the class, ma'am. Ma'am, are you there?
Yes, sir.